Fine art fosters problem solving skills by challenging us to observe, analyze, and adapt. Learning to draw sharpens our ability to visually solve problems by breaking down complex subjects into manageable components. These skills extend beyond art and can be applied to activities like cooking, crafting, or even fixing household objects. Problem solving in art is an invaluable exercise in critical thinking and creative adaptation. When working with shape and form, a foundational technique involves breaking down an object into basic shapes. While not all artists use this method, it is an excellent way to approach new or complex subjects. Start with a light pencil and sketch the object as a collection of simple geometric or organic shapes, sub-objects if you will. This stage allows you to adjust proportions and spatial relationships to ensure they imitate the subject accurately. Any distortions in these proportions should be intentional, not accidental. Once proportions are corrected, the next step is to define contour lines with darker pencil strokes, adding detail and clarity to the object's boundaries. From there, shading is used to transform flat shapes into the illusion of three-dimensional forms. By mimicking how light interacts with the subject, shapes take on depth. The play of highlights, midtones, and shadows reveals the geometry of the form, turning a simple circle into a sphere or a square into a cube. Drawings are inherently two-dimensional, but they often create the illusion of three-dimensionality. By manipulating light, shadow, and perspective, we trick the eye into perceiving depth and volume. However, some shapes remain intentionally flat, prioritizing simplicity or abstraction over realism. As such, there are varying degrees of representation in how shapes and forms are conveyed in drawings. Shapes are defined mathematically using principles of Euclidean geometry developed by the Greek mathematician Euclid in 300 BCE. Today, digital 3D forms are created using more advanced math, including vectors and B-splines, which build upon this ancient foundation. While these tools are essential in digital design, they are not necessary for traditional fine art. Instead, a fine artist focuses on understanding proportions and relationships intuitively rather than relying on complex algorithms. What truly matters is the ability to recognize how shapes and forms carry meaning in art. Though math can quantify these elements, the viewer's experience is not about equations, it's about the visual impact of shapes and forms within the artwork. Proportion plays a crucial role in both shape and form. In human anatomy, for example, ratios govern the relationships between different body parts, such as the size of the hand compared to the face. These proportional rules, used consistently across art history, create harmony and realism in figurative work. Our perception also influences how we see and interpret shapes and forms. The mind can play tricks, forming images out of unrelated shapes. For example, Salvador Dali's surrealist paintings often create double images that encourage the viewer to see one thing morph into another. Similarly, a Rorschach test demonstrates how our brains assemble meaning from abstract shapes using familiar proportions and shapes. Perspective is another fundamental aspect of working with shape and form, especially in depicting objects like architecture. One-point and two-point perspective techniques allow artists to represent three-dimensional forms on a flat surface. Shapes like rectangles and quadrilaterals can be transformed into receding planes through careful attention to vanishing points and proportional scaling. For instance, a row of dominoes can be measured as a series of quadrilaterals that grow smaller as they recede in space. Light and shadow interact with forms to create the illusion of depth, to effectively add lighting to a drawing. 1. Define the light source. Is it a spotlight, sunlight, or candlelight? 2. Lightly sketch the areas where the light falls and where shadows are cast. 3. Observe how the light interacts with the object. Some parts will remain in shadow, while others may have highlights created by reflected light, e.g., light bouncing off a surface onto the shaded side of a curved object. As an exercise, observe an object in strong light, such as a tree at midday or a candle-lit scene. Study how the light source interacts with the object's surface. Imagine lines of latitude and longitude running across the object, like a globe. Which parts are illuminated? Which fall into shadow? These imaginary lines help describe the object's volume and guide accurate shading. To visualize an object's surface, you can think of it as being mapped with a coordinate system, like Cartesian coordinates. Invented by René Descartes in the 17th century, Cartesian geometry revolutionized mathematics by merging algebra with geometry. This system allows geometric shapes and curves to be described mathematically, which forms the basis of 3D modeling in digital art. In drawing, you don't need to formally apply Cartesian coordinates, but you can use the concept of orthogonal lines to suggest volume. For instance, a tattoo on a rounded body part will curve along the surface, following the underlying form. These lines can be imagined as contour markers that help you depict the volume of an object realistically. Mastering shape and form is an essential skill for any artist, as it builds the foundation for more advanced techniques like perspective, proportion, and shading. By studying the relationships between light, shadow, and geometry, artists can transform flat shapes into lifelike forms. While math and geometry underpin much of this process, the ultimate goal is to create visually compelling art that resonates with the viewer on an intuitive level.